Welcome to Angles and Acid, where we learn things maths and science, and we are looking into fractions still. So this is our third episode, and we're specifically going to focus on mixed numbers and how to convert them. So let's get started. A mixed number is a combination of a whole number or a few whole numbers and a fraction. So I've got here 2 and 1/3. And a way of visualizing this is if I've got some pies again, this is just easier to work with, so I'm always going to be using these pies. But if I've got, it's basically telling me I've got 2 wholes and a third left as well. So that means that all of this, and only one piece from that last pie. And something that you'll have to do quite often in maths is to convert the mixed number into an improper fraction, where you've basically taken that whole number and incorporated it or absorbed it into the numerator, and therefore you can do a bit more maths more easily. So let's look at that. Well, how many thirds is that? Well, I could just count them now that I've done a visual here. So I've got 1, 2, 3, 4, 5, 6, 7. I have had 7 slices, seven lots of 3s, or 7 thirds. But you can't always draw these pies, especially when the fractions and the whole numbers are much bigger. So there must be a better system that we can use that gives us the same result, but is an easier method. So here I've color-coded it, all psychedelic colors here. For the same question, 2 and 1/3, I'm going to show you the mathematical approach that we can use. This is going to be the same thing as, so I'm going to keep that line from the numerator for the fraction. And I'm basically going to grab that 2 wholes multiplied by the 3 slices, because 2 lots, I've had 2 wholes, and each of them carried 3 slices. How many slices is that? Well, it's 2 lots of 3 slices, therefore 2 times 3. And you can see I'm pulling them from the original mixed number. And now I've got to add whatever the remainder was. So I still have this blue. Oops, sorry, that's not blue. I still have this remainder. Oh God, I'm not picking the right color, am I? 1 all over the original of 3. So this is the way we can do it. So 2 lots of 3, add 1, all over 3. This is the way that we can smash it all together. So 2 times 3 is 6, plus that 1. That gives me a numerator of 7, and the denominator still stays the same. So I get the same answer as that. So here I can use this process for much bigger problems, rather than having to draw out all these pies. So let's do another one, which is a little bit bigger. So here I've got 4 and 2/3. Well, here I can smash it out. So same as I did the working before. I still got my denominator of 3 because I'm trying to incorporate everything into the top. I had my 2 wholes, and each whole had 3 slices in it. So that's 4 lots of those 3 slices to give me the 4 wholes. And then I add over that remainder that was still sitting up there in the first place, the 2/3. So I add that on top. So now I smash it all together. So 4 times 3 gives me 12. 12 add the 2 gives me 14. So my answer is 14 over 3, or 14 thirds. Another type of problem you will have is to go the other way around, where you start off with an improper fraction and you may be asked to convert that to a mixed number. So how can you do that? Well, there's a couple of approaches I can show you. So the first example here, I've got 12 over 5. Well, we can reimagine this problem as I can basically rewrite the 12, so this number up here, I can rewrite that into a collection of terms, or a collection of numbers all summed together. So as long as that total still adds up to 12, doesn't matter what I sum together. Do you understand? So 12 is the same thing as 6 plus 6. So as long as I have 6 plus 6 over 5, it's still the same question. If I've got 2 times 6, it's still the same fraction. So here's where I want it. Since my denominator is 5, I want to find out how many 5s are possible to fit into the numerator. So 12 is the same thing as 5 plus 5. Now, the reason why I've called out 5 is because that's the value of the base. I'm getting to that in a minute. That's the same thing as 5 plus 5, and I can't go any further. So I've got some remainder, so it'll give me a remainder of 2. 5 plus 2 is the same value as 12, which comes from the original problem. And of course, the base is still there. Now, that is going to be the same thing as 5 over 5 plus 5 over 5 plus 2 over 5. Now, of course, 5 over itself gives you 1. That also gives you 1, so a total of 2 and 2/5. So that's the answer, tonic conversion. But of course, if this is really big, let's say I had something much larger like 50 over 4, okay? Trying to pull out a number of 4s from 50 would take a while. So there must be another way. Here's another method I can show to you, and you can use this method. This one uses long division, and then instead of going into decimals, so I know that you can keep on doing your long division, instead of doing decimals, you can actually use those leftovers as the remainder of fifths. So let's work on it. So how many times does 5, because that comes from here, how many 5s fit into 12? Well, 5 doesn't fit into 1, so I go to the next value here. 5 fits into 12 twice, and that gives me a value of 10. I'll take the difference, so that gives me 2 remainder. So instead of going into decimals like 2 point da 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 da, I'm actually going to use this. I got 2 remainder 2. So that means that 12 divided by 5 is the same thing as 2 and 2/5, because that remainder gets put in that numerator. Let's do another example where it's a bit larger. Here, 49 over 5. Convert this to a mixed number. So we could do the long division method. Let's try that. So let me just make sure I've got the right layer. So 5 into 49. 5 doesn't fit into 4. 5 fits into 49. Well, I can fit 5 into 45 and have some leftovers. So 5 times 8 gives me 40, so 5 times 9 probably gives me 45. So I'll probably fit 9 of them. That will give me a result of 45. Take the difference. How much is remaining? I get a remainder of 4. I remember the same problem we had previous, where this becomes our remainder. So the answer is 5 wholes and 4/5. I hope that makes sense. I think I went a little bit quick. But maybe if you watch this video back maybe a couple of times, or maybe in slow motion, it'll make more sense to you. Here, before I end the video, I want to give you some things to practice on. So here, trying to convert things from mixed number into improper. The second question, where you start off with the improper, and you got to convert that to mixed. Hope you guys liked the video. I will catch you in the next episode. Thanks.